Now we're going to begin to completely factor each polynomial we see. So based on the fundamental theorem of algebra, because this is a fourth degree polynomial, we are expecting 4 zeros, and the complete factorization will contain 4 factors. First question, can we factor this? And I'm hoping you're looking at that and saying yes. It's an x to the fourth with an x squared with a constant, and it's 3 terms. So x squared and x squared. 36, I do plus 9 and minus 4. I'll get a negative 36, and in the middle I will get 5x squared. This is now a difference of 2 squares, so I can continue my factoring. Probably at present you don't recognize that, and we don't normally factor a sum of 2 squares. So if you don't recognize it, set it equal to 0 and solve it. Plus or minus 3i. So what we found in breaking this thing down is we found 2 of the zeros, 3i, negative 3i, and 2 of the factors. But if this is a factor, right, x plus 2 is a factor, then x equals negative 2 is a 0. And if x minus 2 is a factor, then x equals 2 is a 0. So now we've got all 4 zeros. 2 of them are actually x-intercepts. 2 of them are just imaginary. But our complete factorization would then be x minus 3i, x plus 3i, x plus 2, x minus 2. And if I multiplied those 4 factors together, I would get x to the fourth plus 5x squared minus 36. So now, the next time you see x squared plus 9, think about factoring it as the imaginary pair x plus 3i, x minus 3i. Okay, let's try another one. X to the third plus 3x squared minus 48x minus 144 with the hint that x plus 3 is a factor. Okay, so it is a third degree polynomial. So we are expecting 3 zeros, and the complete factorization will have 3 factors. If you're looking at that and saying, hey, I could factor that by grouping, go right ahead. It's probably faster. I'm going to use this hint, and I can use it in one of 2 ways. Since it was given as a factor, I could do it with long division against that polynomial. But since it's an x plus 3 factor, I think I'm going to do synthetic division with negative 3. So I have a 1, a 3, a negative 48, and a negative 144. 3 times 48, 24, regroup the 2, 144 positive, 0 remainder. That's what I'm looking for when I do my synthetic division. I'm looking for a 0 remainder. If I don't get a 0 remainder, it either means that the thing I tried to check as a 0 isn't really a 0, or I made a math mistake. Okay, so what we've got is that's a factor. We've confirmed it. So negative 3 is one of the zeros. If I had another factor or another 0, I could layer in another synthetic division. And in the next video, we'll have an example of that. And you'll end up doing that quite a bit. But this has gone from being a third degree polynomial. We broke it down, and now we've got a second degree polynomial, x squared plus 0x minus 48. I can choose to do a whole lot of things with this, but I'm just going to set it equal to 0 and find My remaining two zeros by solving that, plus or minus 4 square root of 3. So 4 square root of 3 and negative 4 square root of 3. So those are my three zeros. X plus 3 is a factor then. X minus 4 root 3 and x plus 4 root 3. That's my complete factorization. If I multiplied that out, I would get x to the third plus 3x squared minus 48x minus 144. One more in this video. Here I have a third degree. So I'm expecting 3 zeros, and my complete factorization should have 3 factors in it. No one gave me a hint. If I tried to factor it by grouping, I'm going to have problems over here. So I'm going to go to the graph and take a look and try and get a hint for myself. The numbers that I'm looking for would be factors of negative 3 over factors of 1. So 3 over 1, negative 3 over 1, 3 over negative 1, negative 3 over negative 1. So I'm looking for lots of, I could also have 1 over 1 or negative 1 over 1, because 1 and negative 1 are also factors of 3. I may have repeated myself a million times. Sorry about that. Okay, so I've got the equation in there. Hopefully I typed it in correctly. And let's go to the graph. Hello, graph. Okay, so it looks like something's happening near 4, but there was nothing 4 about what I was looking for, and that doesn't look exactly right. Something's happening near 0, but I don't think it's exactly at 0. Something's happening at negative 3, and again, I could use my calculate menu. Sorry. To actually calculate a 0, but I'm going to take a chance. Come on, graph. On negative 3. So I'm going to minimize this. I'm going to take a chance on negative 3. So questionably, question, negative 3 as a 0. So I'm going to test that with synthetic division. 1, negative 1, negative 13, negative 3, 1, negative 3, negative 4, positive 12, negative 1, 3. Hey, it works. So now I can erase my question. It is not a question anymore. It is definitely a 0. I went from third degree. This is now x squared minus 4x minus 1. And that won't factor. I didn't see anything else out there good to use. So now I'm going to do quadratic formula to find my other two zeros. Opposite b plus or minus square root b squared minus 4ac all over 2a. 4 plus or minus the square root of 20 over 2. 4 plus or minus 2 root 5 over 2. I'm going to factor out a 2 and cancel it with the 2 in the denominator. So I get 2 plus root 5 and 2 minus root 5 as my last two zeros. So x plus 3, x minus 2 minus root 5, and x minus 2 plus root 5. See these as x equals, and then I move it over. X equals, so I subtract the 2, I subtract the root 5, I subtract the 2, I add the root 5. So if I multiplied all this back out, I would get that. So those are our first three examples.